Hello YouTube, welcome back to my channel. So guys, today's tutorial we're going to go ahead and create a simple cryptocurrency, just a crypto coin using Solidity, and you're also going to practice how to deploy to an actual testnet and all of that functionality. So you guys, if you're new to the channel, please kindly consider subscribing, liking this video, and sharing this content with anyone who you think might find this helpful. So let's get started to it. Okay guys, welcome back. So in this what you need to do, the first thing, you're going to go ahead and write this on the internet. You're going to be using Remix. So if you've ever done blockchain or ever created something using cryptocurrencies, then using a blockchain or any other Ethereum network or stuff like that, you probably came across Remix Ethereum IDE. So if you haven't come across Remix Ethereum IDE, you can just go to remix.ethereum.org, and then you get this editor to use for free. So in here you can write your Solidity contracts, your blockchain contracts, and then deploy them and test them out on different platforms. So you can actually write them here and then deploy them locally or using a JavaScript virtual machine, or you can just actually deploy to an actual testnet and do all that functionality. So this we are going to first begin to write our contracts, and after we finish writing our contracts here, we are going to move all the functionality we're going to also write the same contract using Brownie. Brownie is a Python library for creating blockchain contracts in Python. So we're going to move everything to Brownie. You're going to write it again from scratch. You're going to move the code over there, write some tests on it, deploy to an actual network, so you guys can understand how to actually use Brownie in deploying contracts on the web. Okay, so let's get started to it. So the first thing I'm going to do, I'm simply going to go into my contracts first. So if you go to remix.ethereum.org, this is what you get initially. I think you have to sign up. I don't remember the process, but once you are signed up or you get access to it, you go into contracts and then click on file. We're going to simply call this, I'm going to call it coin.sol. So sol is a file extension for Solidity. So Solidity is a programming language that is used to build blockchain contracts and stuff like that. So we're going to be using Solidity for this tutorial. So let's get started to it. So now that I'm in my file here, the first thing I'm going to do, I'm going to go ahead and specify the SDPX license identifier. So that's the first thing you need to do for all of your Solidity contracts. So I'm going to say SPDX and then XPDX hyphen license. So license, just like this, and then you're going to say identifier. So license identifier, just like that, and then I'm going to spread that is going to be GPL, and then the GPL is going to be hyphen 3.0. So this is something that you have to specify for all your Solidity contracts. So once we have this specified, we can go ahead and specify the version of Solidity that you're going to use. So I'm going to say pragma, just like this, and then you can simply go ahead and specify the Solidity that you want to use. And I want to use Solidity anything from above 8.4, just like that, 0.8.4. Let me just keep this. I can usually 0.8. That's also not bad. You can use 0.8 if you want. So just say 0.8, and that should also work for you. Yeah, so once I have that created, I have that created, I'm going to go ahead and create my Solidity contract. So to do that, I'm just going to say contract, just like this, and then I can give the contract a name. In this case, I'm going to simply call my contract a coin, right, because it's just a crypto coin that you're trying to create. So once I have that, that's all I need to do to have the contract set up. So once we create this contract, right, whenever a person creates this contract, you want to know the person who created this contract, right? That is going to be the minter of this specific contract, right? So to do this, you're going to have a constructor. Just like in other programming languages, constructor is the first thing that gets called whenever a certain class is called, or whenever an object is created, right? So whenever this contract is created, the first code that to be executed is a contract, right? You're going to want to set the owner of this contract. So we're going to now have going to say contract, just like this, contractor, just like this, instead of not contractor, and then this contractor is going to say the following. So I'm going to say minter, and the minter is going to be the msg.sender. So MSG, the sender, is the person who calls this contract. Now minter, we haven't created minter, so we have to go up here and then create that minter. So the minter is going to be of type address. So address, and you're going to say it's going to be a public address. So public means anyone can access it outside of this contract. And you're going to simply call it minter, just like that. So I've created the minter here. We're giving Solidity is a statically typed language. So you have to set a data type, which is going to be an address type, and then it's going to be public, and it's going to be called meter. And now in the constructor, just saying the meter is going to be the person who created this contract, which is going to be msg.sender, right? So now that I have that created, I'm going to go ahead and simply create some functions, and this function will help to mint the contracts and stuff like that. So I'm going to create a function, which is a function, and this is going to be called mint, which is going to help the person to mint the contract. So this contract is going to be called by it's only going to be called by the creator of this this function. Rather, can only be called by the creator of this contract. So let me just say can only be called by creator of the contract, right? So this function can only be called by the creator of that contract, right? No one else can call this this function. So how do we make sure that only the creator of this contract can call this function? So to do this is actually very simple. So in Solidity, you just have to say require. So right, so this contract can be used by the creator of this contract, right? This function rather can be used by the creator of this contract to send money to, or to mint this coin to anyone he wants to. So he can even send the coin to himself, can send the coin to any amount. So he can call this function and then be able to mint the coin to anyone or any address that is specified. So the first thing we're going to, let me just delete this for now. So the first you're going to get in here is the address that he wants to send this to. So address, the address is going to be, we're going to call this the receiver. So this is going to be the receiver of that amount, whatever amount the person sends, and then whatever amount the person sends, and then you're going to now take in the amount that the person needs to be sent. So you're going to say you int 256. That's going to be the amount the person can send, right? The amount that the amount that he wants to mint to a person, right? You're going to simply call this amount, and yeah, you're going to make this function a public function. So we're going to say public, just like that. Yeah, so once we have that done, that's all we need to do. So we're going to pass in an address of the person we want he wants to mint the coin to, and then the amount that he wants to mint, right? So now we have to make sure that the person who is actually calling this this function is the owner of this contract, right? Is the minter of this contract. So we're going to say require. To do this in Solidity is actually very simple. You have to say require, and you have to pass in a condition here that boolean condition, right? So msg.sender. So msg.sender should be equals to the minter, okay? The minter. So if this is true, right, means that the person who is calling this function is actually the owner of this contract, right? If this is true, if this is true, then we are going to allow the person to do whatever we are going to keep below this statement. Else you're going to simply pass in a message to tell, in case this is false, you're going to tell the message that you are not the owner of this contract, right? So just to tell the user that he is not the owner of this contract. So in Solidity, one thing also notice that I end every line with a semicolon. So you have to end every line with a semicolon. Okay, so once I have that done, so I'm going to now go ahead and actually add the money into the account of the receiver, right? So what I'm going to do, I'm going to go ahead and maintain a mapping here. So the mapping is going to map the address to an amount that is stored in that specific address. So I'm going to have something called a mapping. So if you're going from other programming languages like Python, we call this dictionaries, okay? So in other programming language called hash maps, I think. Yeah, like in Java it's called the hash map. Even in C++, I believe it's called the hash map. So you're going to have a map here, and you're going to map the address to the uint of to uint 256. So we're going to have uint 256, and you're going to simply this function is going to be a public function. So public, and you're simply going to call this balances, okay? Balances, just like that. So whenever a person whenever the sender is the one the caller of this function is the sender, now we want to go ahead and send the money to that account. So we're going to say balances of the current receiver is going to be, you're going to add to it, right? You're going to say plus equals to the amount that he wants to send. So in other programming language, in other types of when people coding in Solidity, they use underscore for when they're accepting arguments. So you can also use an underscore here if you want. That's no problem. Yeah. So even here you have to say underscore, right? So if you use underscore there, you also have here to say underscore, but it's not a must. If you don't want to use the underscore, it's also fine. Okay, so here you're going to say the address of the receiver, the amount stored in that account is going to be plus equals to the amount that the user the owner of this contract specified, right? So once we have that, we can simply emit an event and to let the person know that the transaction has been successful. So we can go ahead and create an event here, and to create an event is very simple. So I'm going to go here and say event. So I'm going to create an event here, and I'm going to call minted, just like that. I'm going to call this event minted. I'm going to take in the address, and this address is going to be from, and the uint, just like that. And this is going to be uint, let's say uint 256, and this is going to be the amount, right? So just like that. So this event takes in the from and then the amount, right? So this can be a comma right here, so my bad, comma right here. So once we have that, I'm still going to go ahead and call that event. So I'm going to emit that event. So calling the events in Solidity is called emitting an event. So I'm going to say simply say emit the minted event, and the minted event just simply going to pass in the following. So it takes in the sender, right, from the person. So it's going to be msg.sender. So msg the sender is the person who actually making who is actually sending the money. In this case, instead of saying msg.sender, you can also just say the minter, because the minter is the only one who is required to call this account, right? So it's going to say underscore amount. So the minter send this amount, right? So that's the kind of message that is going to be emitted. So that's how we to handle an emit event. So great. So once we have all of that done, we can go ahead and write the function to actually send the money. So for example, I have a coin, right? A sender has sent a certain amount of coin to my address, right? And I want to send that coin to someone. So I'm going to create a function to do that, because this function can only be called by the emitter. So I'm going to create a function that can be called by anyone. For example, if I want to send money to anyone, I have some coin I want to send to someone, I can just go ahead and send that coin to another person, right? So let's go ahead and do that. So to do that is actually quite simple. So what I'm going to do, I'm going to do the following. So I'm going to say I'm going to create a function. So I'm going to say function, I'm going to say sender, just like this, and this is going to have the following. So we're going to have address, so an address, and this is going to be the address is going to be the receiver, so the receiver, just like that. We're going to take in the receiver, and we're going to take in how much you want to send to that receiver. So I'm going to say uint 256, just like this, and this is going to be the amount, right? So I'm going to use underscore amount. Okay, if you don't want to use the underscore, is also fine. So this is going to be a public function because it can be called outside of this contract. So once I have that done, I'm going to make sure that the person who is trying to send the money is actually the minter of the address, right? So this function can be called by anyone, not only the owner. So we don't need actually to check if a person is actually the minter of this contract, as I said earlier. So that was an error. So you can just go ahead and anyone can call this contract, and then we can send the amount to the address that the person specified, right? So but before you can send any money to, first of all, you have to make sure that you are existing within our account balances, and then the amount that you want to send is you actually have that amount, right? So if you want to send maybe 1 ETH, you have to make sure that you have 1 ETH or more in your account, right? So you can send something that you don't have, right? You can't use money that you didn't earn, right? So we're going to say if amount. So I'm going to say if underscore amount. If amount is greater than or equals to the balance. So the balances, and you're going to get the balances of the msg.sender person who called this contract. So msg.sender, just like this. So the msg.sender is going to return to us the person who called this contract, right? So if that is the case, in case you have more amount in your account, right, you're going to go ahead and simply so if the amount, so actually, sorry, instead of just saying if the amount is only greater than the amount that you have, right, then you're going to simply raise an error here. So you're going to revert this transaction. You're not going to make the transaction go through. So you're going to revert it, and how to cancel the transaction is by using the revert keyword. And you're going to revert it. You're going to go ahead and specify. I'm going to create an event here, an error event to handle this. So I'm going to go up here, and I'm going to create an error. So I'm going to say error, just like this. And error, we're going to go ahead and say insufficient balance, right, or insufficient funds, or insufficient balance. So just say insufficient balance, and this is going to be the following. So it's going to be insufficient balance is going to be uint. It's going to take in uint 256, and this is going to be the requested amount, uint 256, and it's going to be the requested, and then we're also going to split the available amount, and this is going to be uint 256, and this is going to be the available available amount, just like this. So we're going to create an event, an error event here. So we're going to go ahead and say insufficient balance, and then insufficient balance, we're just going to go ahead and say the following. So we're going to go ahead and say this, passing this, and you're going to go ahead and say the following. So we're going to say the requested is going to be the requested is going to be the following. So it's going to be the following. So we're going to say amount, the requested amount is going to be the underscore amount, and then you're also going to go ahead and specify the available. So the available is going to be the amount that is available in the sender's account, right? So the person who called this contracts account. So msg.sender, just like this. So once we have that done, that's all we need. I can just go ahead and end this right here with a semicolon. So once I have that done, in case the person has enough account, right, enough coins in his account, right, the existing coins are enough in his account, we're just going to go ahead and actually perform the transaction. So we're going to say balances, and you're going to get the balances of the person who sends this account, with the person who called this, right, and the person who called this function, and it's going to be msg.sender. msg.sender, and your msg.sender, you're just going to go ahead and say the following. So msg.sender, you're going to go ahead and minus equals to underscore the amount from his account or his or her account, and they're going to say balances. So balances, and the balances, we're going to go ahead and say msg.sender, msg.sender, and sorry, this is going to be the receiver's account instead, not msg.sender. So it's going to be the receiver of the account that the user specified right here. So we're going to simply add plus equals to the underscore amount that the user specified that we transfer to him. So this is going to be the amount, right? So amount, just like that. Yeah, that's all we need, and that's to perform the transaction. Once we perform the transaction, I want to emit a message to let the person know that the transaction went through. And to do that, it's actually very, very simple. So I'm just going to go down here and just simply call the following. So I'm going to go ahead and say an event here, and it's going to be event, and this event, you're going to simply say the following. So we're going to simply say you're going to have this, you're going to send, and you're going to call this event send, and it's going to have the following. So you're going to say the address, and this is going to be the address from address, and then you're going to have an address, going to be to address, and then you're going to have u in 256, and which is going to be the amount that we sent, right? So it's going to be the amount, okay, just like that. So amount, and then we can end this with a semicolon right here. So once we have that done, I'm just going to go ahead and emit this event. So I'm going to go ahead and say emit, and I'm going to say send, the send event, sent rather. Let me call this sent because it makes more sense. So I'm going to call this event sent, and then we're going to go ahead and specify the msg.sender. msg.sender is the person who made this request, right? And then we're going to say the receiver, and then you're also going to pay the amount that was sent. So underscore amount, just like that. So the sender from is going to be the person who called this contract, and then the receiver to is the receiver, and then the amount is the amount that is specified. So this corresponds with this right here. So once we have that done, we can just go ahead. That's all we need for our simple cryptocurrency. It's just a very simple cryptocurrency, so it doesn't involve a lot of complex stuff. So it's actually very, very simple. So once we have this, we can go ahead and deploy this on the blockchain. So I'm just going to go ahead into this section right here. So click on this section, and then go ahead and compile this. So compile it. And once it's done compiling, we can go into this section right here. And I was trying something else previously, so I'm just deploy this. Okay, I'm just delete all of this. Once we have this, I can just click on deploy the contract. So I'm just going to click on deploy, and this is going to go ahead and deploy that contract for us. So sorry, my bad, I actually made an error right here. I'm actually using I connected my Ethereum, my metamask to this. So I'm just going to cancel this and show you what to do. So let's just pop up and let me cancel this. We're not going to be using metamask for now, so let me just cancel this. Let me just reject this transaction. So once we have this transaction rejected, I'm just going to go in here, and then in the environment section, I'm going to go ahead and select the JavaScript VM. So I'm going to use JavaScript VM to deploy this. I'm not going to use my actual metamask to deploy this, right? So once I have that, I can just go ahead and click on deploy this time again, and this should deploy it on the JavaScript using the JavaScript virtual machine. So once it's deployed, we can now see the contract right here. So I can just click on this, and we have our contract right here. So each of these functions that we specified, the mint, the minter is going to be public because it can be seen by everyone. We can also have the mint, which we can mint a coin, and this can only be called by the minter of this contract, right? The person who created this contract, which is us in this case, and this is our address right here. So only this address can call this specific function. And we also have the send, and the send is right here, and this can be called by anyone, and it takes in two things, that right. So you can just go, let me just click on this right here. So it takes in the amount, the receiver, and the amount that you want to send, and also check the balances, and it's going to return to us the balance of that specific address that we passed in. So let's go ahead and try to go and mint. Let's start with minting. So I'm just going to go ahead and get my address. I'm going to go ahead and copy this, and once I have that copied, I can go in here and simply paste it in here. So paste it. And once I have, let me just click on this drop down. I want to mint some amount to this address, right? So you can see that the value that we have here is Gwei. You can send Gwei, ETH, and Fini. Okay, so I want to go ahead and send Gwei. So Gwei is the lowest denominator or division of an ETH. So 1 ETH is equals to 10 times 10 raised to power 18 Gwei. So I'm just going to go ahead and actually copy this. So copy this value, and I'm just type in here 1 ETH. So you can go to this website. It's called ethconverter.com. So in this website, I'm just going to go ahead and type in 1 ETH here, which is equals to, the equivalent is 1 Gwei right here. Or you can also send ETH if you want. So just send ETH, or you can but the simplest, most of the time you find people using Gwei instead, because it's the smallest value of an ETH, right? So we have an ETH, and then we have Gwei, and then we have Gwei. So it goes, the upper we go, it becomes smaller and smaller. So this is 10 raised to power 8, and this is 10 raised to power 19. Power 18, I think, power 16 or 18. I think this is the difference in 8. You can just count the zeros on your own time. So I'm just going to go ahead and actually send 1 ETH, or you can actually send 1 Gwei if you want. So I'm going to copy 1 Gwei, and then just go in here. This is actually not 1 Gwei. This value here, it says 1 ETH, but I'm getting its equivalence in Gwei. So I'm just going to go in here and just simply paste that value that I copied right here. So paste it here, and you're going in the value, make sure that you keep Gwei and not any other. Okay, so once we have that, I can just go ahead and specify the sorry, not here. So I'm just going to I'm just going to copy this and leave it to be 0, and then in here I'm going to go ahead and specify the amount to be 1 ETH, which is this amount of Gwei. So I can just click on transact, and this is going to go ahead and do that transaction. So now we have transferred 1 ETH, which is the equivalent of, this is equivalent in Gwei. We have transferred it into this account, which is our own account, right? The person who created this account. So we have transferred this amount of ETH, which is 1 ETH, which is this amount of Gwei, into our account. So let's go ahead and try to see the balances of our account. So I'm just going to go ahead, copy this. I'm just going to go in here, copy this value from here, and I'm simply going to go in here and simply paste it in the balance section, and simply get a balance. So you can see we have that amount in our account. Great. So this amount right here we have in our account. So I want to go ahead and simply maybe send this amount to someone else, right? So I'm going to go ahead and click on this drop down. So I have clicked on this drop down right here. So I need to pass the receiver and the amount that I want to send, right? So let's say I want to send 1 ETH. So I'm going to copy this, which is the equivalent of this Gwei, right? So paste it here, and which address do I want to send it to? So let me just get another address from here. So I want to get this address, and I'm simply going to copy the link of this address, and I'm going to change back to my address. So once I have this, I'm going to simply paste the address that we just copied right here, and I can simply click on transact. It is going to go ahead and send that money to the person, right? So once we have that, I can simply copy this value that person we send the money to, or we can also actually check our own balance. Right now our balance should be 0, right, because we send all the money to this account. So now let's check this account was the balance instead of this account, and the balance instead of that account is 1 ETH, which is this equivalent of 1 Gwei. So we have been able to transact money between our different accounts. So I can even go in here. Let me say that I try to send another 1 ETH to this person. So this transaction should not go through, right, because I don't have that amount in my account. So it should get reverted, and this should be done, right? So it says let's try to look at the revert, and it says that requested available provider and all this. So you can say we get back this right, requested, the value, and then the available value is 0. We can see it right here. So if I just bring this right here, you can see the available amount is this one right here, and the value that we requested to send is this one, which we don't have in account. That's why the transaction got reverted. So great. let's try to go ahead and send this amount back to our account. So let me just go ahead and change my account. So I'm going to change my account to this value. So let me just copy this first, copy this, and I'm going to change back to this account right here, and I'm going to go ahead and send the amount back to that account. So paste this right here and then transact. Once that transaction goes through, now I can go back and check the amount that I have in my account here. So I'm just going to go ahead and grab this. So grab all of this and simply paste it in here. So now the account of this balance should be 0 because we send the money back to the old account, right? So now if I check this account right here, check its balance, now we should have 1,001 ETH inside of that account. So great. So that's how our simple cryptocurrency is. So that's very, very simple, and we have built it using Remix, right? So we Remix and Solidity. So our contracts work successfully. Now you can deploy this to an actual testnet. So you can just go and let me just go in and just delete this deployment. So I'm just going to go in here and then change this to injected web3, and I can deploy this to an actual testnet. So I'm going to be using my Rinkeby network. So if you have metamask, if you don't know how to install metamask, I'll just leave a link, a document, an article in the description on how to install metamask right here. So if you install metamask, you can also get some ETH. You need some ETH. Okay, so we're going to be using the Rinkeby test network. So I'm going to show you, I'm going to also leave some articles to show you how to get some testnet. So you can also just go in here and just type in the following. So let's say that you can say faucet, I think it's faucet, just like this, faucet.chainlink /link Rinkeby. So Rinkeby is the testnet that you're going to be using. So we're going to be using Rinkeby to deploy our contracts. So if you go into this you can connect your metamask. So if you go at this link, you can just connect your metamask. My metamask is already connected to this website, so I can just go ahead and click I'm not a bot, because I'm not. Click I'm not a bot, and once this is done, you can just request them to send you 0.1 ETH, and this 0.1 ETH is actually fake money. Okay, so it's actually not something that you're actually going to be using to buy stuff with or make you rich. Okay, if it was like that, then everybody will be just making requests, right? But this is actually fake money, so you won't be able to use it to do anything in the actual world. So it's just some fake money to help you to deploy your contracts, okay, and stuff like that. So you can see that transaction went through and we got back. So I'm just going to expand this, and that transaction went through and we got back 1 ETH, 0.1 ETH. So I can just go ahead and close this, and if I check in my metamask, I should see that information right there. So this, we can see it was previously 3 point something, but now I got this. So even if I make the request again, you can now it's 4 point something. So if I go ahead, click again I'm not a bot, and I can just make a request again, I should take some time, and now you can see right now it's 0.4 something. So now you should receive some amount again. You can see receive this amount 0.8 ETH on the 28th of April, which is the current date, right? So right now you're going to, if you just make another request, you're going to get another 0.1 ETH, which will take this to 0.5 something. Yeah, and I'm using my Rinkeby network, so I'm going to show you how to set up your, I'm going to leave the link in the description, an article of how to download and install metamask and how to set up your chain link and stuff like that. So I'm going to leave all that in the description so that you guys can get access to that information. So you can see we received another amount. Now it is 0.5. So yeah, that's how you can get a test ETH if you're using a metamask. So the website for this is going to be called faucets.chainlink.chain.link /Rinkeby. Okay. Yeah, so that's how you can get test Ethereum to test your to deploy to an actual testnet. So just change this. Now that you have some test Ethereum on your MetaMask, so change this to be injected Web3 in the environment section. Change it to be injected Web3, and you can see that Remix has already picked up that I'm using a Rinkeby network, and the ID for Rinkeby is 4. That's why it's 4 is here. So once I have that, I can simply deploy this. So I click on deploy. It's going to take some time. It is going to deploy this to an actual testnet. So my MetaMask is going to pop up, and then it's going to ask me to confirm the transaction. So I'm going to go ahead and to confirm the transaction, because we need to pay some gas fees right here. So I'm going to go ahead and click confirm, and once I click on confirm, it's going to go ahead and send that send the coin over there, and my transaction is going to be, my contract is going to be deployed on the Rinkeby network. So I can just simply click on view on Etherscan. So you can go to Etherscan, and then you can just paste your address contracts in here, and then you get the contract that you're looking for. So in this case, you have deployed a contract. So I'm just going to close this, and you can see the contract has been deployed, but now it's pending, so you have to wait a bit for this contract to go through. So this is a contract, the transaction hash. So you can just copy this, and you can go to Rinkeby and then just paste it in here, and then you can be able to get access to the same network information. So you can just click on this. This should take some time. If you don't get anything, make sure that you change this to be just go to Etherscan and then change this to be Rinkeby network. So just change this to be Rinkeby, just like that, and then simply once you have the Rinkeby testnet, you can just go ahead here and then paste in that and then make a request. Now you should get back that contract. Now you can see that it has been successful, and if I go back here, you can also see it is still pending here. So I think we need to refresh this. So we need to refresh this a bit, and let's see what we get. So you can see now it has been successful. So that's how you can deploy your contract on an actual net. So now if you are using you're trying to build an application, you can just use this address to get access to this contract, right? Yeah, so that's basically it on how to create a simple cryptocurrency using Remix, and then be able to deploy it on an actual testnet. Okay, so let me just close all of this up, and this is a link to get some fake Ethereum. So once I have that, I'm just also going to close. I can leave this one here. Yeah, so once I have that, that's all we need for that to work. So in the next tutorial, we're going to go ahead and simply build this using a blockchain, right? Using an actual Python application on our local machine. So see you in the next one, and I'm going to show you how to do this using a Brownie, which is a Python library for working with blockchain. So yeah, if you haven't subscribed to the channel, please kindly consider subscribing, liking this video, and sharing this content with anyone who you think might find this helpful.